In 1910, a commercial beekeeper in the Indiana clover belt opened one of his strongest hives and found two queens, both laying, both attended by their own workers, both operating in the same structure as if the other did not exist. He did not remove one. He did not hesitate or panic. He closed the hive and walked to the next one, because he had put both queens there himself 6 weeks earlier, and he knew exactly what he was looking at. That is the beginning of this story. That is the beginning of this story. The end of it is why that method, yield-tested, commercially proven, refined across nearly 2 decades of apiary practice in the Ohio and Indiana clover belt, vanished so completely that most beekeepers alive today have never heard it named as a deliberate technique at all. Every spring for about 20 years, the beekeepers who ran this system had a window, roughly 3 weeks wide, arriving in late May in most years, when their colonies were producing at a level nothing else in the apiary could match. Not in forager population, not in surplus yield, not in what the honey house looked like at the end of June. And then the method closed, the window closed with it, and nobody wrote down exactly why. Most beekeepers today, opening a hive and finding 2 laying queens, would treat that as a problem requiring correction. Find the older one, remove it, restore what they recognize as order. That instinct is not wrong in the context of most modern management. But in 1910 Indiana, that instinct would have cost a season. Before this method can be understood, one number has to be held clearly in mind. Not as an abstraction, as a ceiling. A productive, healthy queen at her biological peak lays somewhere between 1,500 and 2,000 eggs per day. That is her limit. No feeding program raises it. No management decision changes it. No equipment configuration expands it. The ceiling is fixed by her biology, and every egg she lays enters a developmental pipeline that takes exactly 21 days to produce an adult bee. That adult bee then spends another 21 days as a house bee, feeding larvae, processing nectar, cleaning cells, building wax, before her hypopharyngeal glands regress, her flight muscles strengthen, and she makes her first orientation flights into the field. 42 days. Egg to active forager. That is the pipeline every colony runs every season, without exception. In a colony trying to build a forager force for a nectar flow that peaks 6 weeks away, the arithmetic barely works. The eggs laid this morning will not contribute a single foraging trip to the primary clover flow. The eggs laid 3 weeks from now, the ones the queen is producing while the beekeeper is watching the bloom calendar and wondering whether his colonies are ready. Those bees will emerge during the flow but spend the peak weeks of it as nurse bees. A single queen, even a young and vigorous one working at her biological ceiling, cannot fully populate the 6-week demographic gap between where a spring colony is in early April and where it needs to be when the clover opens in mid-June. Her ceiling is fixed. The flow does not wait for her. That gap between what a single queen can produce and what a peak nectar flow rewards is the problem the 2-queen system was designed to close. And it was closed not by asking the queen to do more, but by doubling the number of queens doing it. If this kind of biological reasoning, working from the math of the hive rather than the appearance of it, is the kind of content that changes how you read your colonies before the flow, a like or subscribe helps this reach other beekeepers who think the same way. And I would genuinely like to know, have you ever run 2 queens in a single hive, deliberately or by accident? Leave that below. The first-hand experience from people who have seen this matters more than any general account. Here is what most people get wrong about the 2-queen system before they even understand it. They assume the central management problem was preventing the queens from killing each other. It was not. That concern is real in the wrong context. Queens encountering each other in open, undivided brood space will fight. That is accurate and consistent bee biology. But queens operating in physically separated brood zones, each with her own laying territory, her own attending nurse population, her own established spatial range within the hive, those queens can coexist in the same wooden structure for months without the workers ever presenting one to the other. The divider was not a stopgap against an inevitable conflict. It was a managed condition, a condition that, maintained correctly through spring, allowed both queens to lay to their biological ceilings simultaneously. The queens didn't fight. That was the first thing most beekeepers who heard of this method got wrong. And getting that wrong was enough to prevent them from understanding what the method was actually for. The physical setup varied by beekeeper and region, but the structural logic was consistent across the Indiana and Ohio operations that documented this practice. 2 full-depth hive bodies stacked vertically. One entrance at the base of the lower box for the lower colony's foragers. A second entrance, notched into the upper side or drilled through the upper face, for the upper colony's foragers. Between the 2 boxes, a dividing board, solid except for a screen insert that allowed air exchange and limited pheromone diffusion without allowing queens or workers to move between chambers. In the earliest practice, the divider was a simple wooden partition. By the 1910s, some operators were using a configuration close to what a queen excluder would later formalize. A barrier that workers could pass through but queens could not, allowing the forager populations to intermingle while keeping the queens in separate laying zones. That variation had meaningful consequences for how the merger eventually resolved, which is worth returning to. The previous season's queen occupied the lower chamber through winter and into spring. A young, newly mated queen, introduced in early April, occupied the upper. Lower foragers left through the bottom entrance and returned to the bottom entrance. Upper foragers left through the upper opening and returned to it. These were not the same colony. They shared a hive body. That was the extent of what they shared. What they did not share, and this is the mechanism the method was built on, was brood space limitation. A queen constrained by the architecture of a single brood nest, honey pressing down from above, pollen and incoming nectar packing in from the sides, her available laying space contracting even as the colony's population was building. That queen is producing at a fraction of her biological capacity by the time May arrives. The beekeeper inspecting in late April sees wall-to-wall brood and concludes the colony is positioned for the flow. The demographic math says something different. That queen has been slowing for weeks. The cells she needs are not available. She is not failing. She is imprisoned by the architecture that her own productivity helped create. Her daily egg output has dropped below her ceiling, and the 42-day pipeline has thinned accordingly. The 2-queen beekeeper was watching something entirely different. 2 queens, each in a brood nest that had not yet compressed, each laying into space that was still open, still accessible, still responding to her output. The divider wasn't keeping them apart. It was keeping them working. Both pipelines running from early April, full and uninterrupted, through the weeks when a single queen colony was already losing production to brood nest compression. By mid-May in the central Indiana clover belt, a 2-queen colony that had been running since early April was carrying a population that exceeded most comparable single-queen operations in the same apiary by 30 to 40%. Not because of better genetics, not because of superior forage access, because the developmental pipeline had been doubled for 6 weeks, and 42-day math, when you run it twice, produces a different number than when you run it once. This is where the 3-week window opens, and where the decision that separated a good season from an exceptional one had to be made precisely 3 to 4 weeks before the anticipated peak of the primary clover flow. In central Indiana and much of the Ohio clover belt, that peak arrived in the 3rd week of June. The divider came out. Not gradually, the board was removed. The 2 populations, each carrying their queen, each with their forager force, each with their brood nest in mid-development, were merged into a single hive body. And what happened in the 24 to 48 hours after that removal is the reason the beekeepers who ran this method kept running it. This was not what most people understand as a hive merger. When two separate colonies are combined, two hives that have been managed in different locations, whose foragers have been orienting to different points for weeks, the behavioural disruption of merger is real and temporary. Foragers from the relocated colony cannot immediately reorient. They drift, return to where their entrance was, cluster and eventually integrate. There is a period of behavioural reorganisation that costs the combined colony productive time during a flow. That is not what happened in a two-queen merger where both populations had been foraging from the same structure all spring. Lower foragers had been returning to the bottom entrance of this specific hive since April. Upper foragers had been returning to the upper entrance of this same hive since April. When the divider came out and the two populations encountered each other internally, the behavioural familiarity was already there. These bees knew this box. They knew this location. The forager consolidation was not a merger in the disruptive sense. It was a convergence of two populations that already shared a home. The combined foraging force did not need to reorient. It needed only to work. The queen conflict resolved as it always does. The younger, more vigorous queen typically prevailing within 24 to 48 hours. What remained was a single colony with no disruption to its foraging behaviour, no queen transition underway, no rebuilding from a swarm event, no demographic gap to close. A colony entering the nectar flow with a forager workforce at the demographic peak that 6 weeks of doubled development had produced. If this biology-first reasoning is the kind of content that fits the way you approach your apiary, subscribing keeps more of it coming your direction. C.L. Farrar, whose 11-year documentation of colony population dynamics produced the most rigorous American data on production efficiency in the mid-20th century, provided the formal language for what the 1910 Indiana operators were observing empirically. The relationship between colony population and surplus honey production is not linear. A colony of 60,000 bees does not produce twice what a colony of 30,000 produces. It produces substantially more, because larger colonies operate with a more favourable ratio of foragers to non-foragers, more efficient nectar processing chains within the hive structure, and more comb surface for dehydrating incoming nectar before it can be capped. The two-queen colony entering the clover flow at 65 to 70,000 workers, a figure achievable in the best seasons when both queens had been working unimpeded since early April, was operating at a demographic threshold where the efficiency advantages compounded rather than added. Each additional forager in a colony of that size contributed more surplus than the same forager would have contributed to a colony of half that population. The documented yield differentials across the Indiana and Ohio operations that ran the two-queen system ranged from 20 to 40% above the single-queen average on the same apiary. Same forage, same weather, same equipment. In lean nectar years, that differential frequently separated operations that pulled extractable surplus from those that merely maintained winter stores. In strong nectar years, the demographic advantage allowed the merged colony to process the incoming flow faster than competitors, filling supers that would otherwise have missed the moisture content threshold for capping during the most productive 2 weeks of the flow. The merger window was where the method demanded the most precise judgment. 3 to 4 weeks before the anticipated flow peak. Not 5 weeks, merged too early, and the colony built and then aged its peak forager cohort before the clover opened. Not 2 weeks, merged too late, and the colony spent the first critical days of the flow absorbing the disruption of integration rather than capitalizing on incoming nectar. 3 to 4 weeks, no margin for approximation. And the only way to time it correctly was to know the bloom calendar on that specific land, with the precision that came from years of watching the same fields open in the same season. Not a general rule, a local observation accumulated and applied. Now the disappearance. Because this is the part most accounts either omit or explain incorrectly, the two-queen system did not fail. The commercial operations that ran it reported yield results that the population arithmetic fully explains. The management complexity was real. A second queen to source and winter, a divider to build and maintain through spring, a second entrance to manage, a merger to time, against a bloom calendar that had to be read accurately. The beekeepers who ran it consistently reported that the complexity was proportionate to the return. The method was not abandoned because the results stopped coming. The first change came through the 1910s and 1920s, as commercial queen rearing operations established themselves across the southern states and catalogue purchasing of mated queens became widely available to American beekeepers. The management culture reorganized around purchased inputs. A beekeeper who could order a replacement queen by mail did not need to manage an overwintered queen with the precision the two-queen system required. The older queen, whose continued productivity through winter and into spring was central to the lower chamber of the setup, became a product to be renewed rather than a biological resource to be assessed and utilized through a second season. The knowledge of how to read a second-year queen's productive state, how to time her spring output against the brood calendar, how to position her in a divided hive so that her declining production was augmented rather than replaced. That knowledge was no longer commercially necessary. You ordered a new queen. You ordered two. The second change came in the post-war period, when standardized management routines and Langstroth equipment configurations became the dominant operating model for commercial operations managing hundreds of colonies across production schedules. The two-queen system required a hive configuration, two brood chambers with separate entrance conditions, managed in parallel through the spring build-up, that did not fit the standardized inspection routine cleanly. It required beekeeper judgment that could not be easily delegated to workers who had not learnt the method deeply. Single queen management was simpler to scale, simpler to supervise, and fully compatible with the package B and miticide inputs that were becoming the industry's primary production tools. When a colony swarmed or failed or produced poorly, a package could restore it within a season. The 20 to 40% yield premium of the two-queen system was real, but it required a management investment that the new commercial model had found ways to work around. The method ended not with a rejection, but with an erosion. Individual practitioners retired or shifted practices. Commercial operations changed hands. The extension literature moved toward the management approaches that fit the emerging commercial model. What remained in the published record by the 1940s was a general awareness that some early operators had experimented with dual queens in a single structure, a historical curiosity, a technique that some had tried, rather than a tested protocol with a well-documented biological rationale and a measurable yield record. Nobody wrote a formal conclusion, nobody called it a failure, nobody decided to stop. The decision made itself, one season at a time, as the people who knew the method stopped being the people shaping what beekeepers learned. The biology has not changed. A queen still lays to her biological ceiling, and no further. The 42-day developmental pipeline still determines what a colony's forager cohort will look like 6 weeks from any given moment. A colony built on doubled brood production through the spring window still enters the primary nectar flow at a demographic level no single queen colony on the same timeline can match. The merger dynamics, two forager populations that already know the same structure, converging into a single colony without the behavioural disruption of a true two-colony combinations, still produce the large, flow-aligned forager force that Farrar's data described, operating at non-linear efficiency. None of this has changed. The equipment to run it exists in every well-stocked apiary. The management requirements are real, but not prohibitive. The bloom calendar that makes the timing possible is the same calendar that determines when to add supers. What changed was the beekeeper's relationship to this kind of knowledge. The management culture that replaced the two-queen system was input-driven and reactive. It responded to what was visible in the hive during visits. It relied on products that could be ordered in advance of the season rather than on timing judgments that had to be developed across seasons of direct observation. The two-queen system required the second kind of knowledge. It required knowing what a merged colony's forager force would look like in 3 weeks, based on what 2 brood nests looked like today. That is not the knowledge that a catalogue can provide. It is the kind that comes from watching the same method across enough seasons that the outcomes become predictable. The beekeeper in the Indiana clover belt walked back toward his honey house at the end of June, and the supers told him what he already knew before he pulled them. The weight was there. Not luck, not weather. The result of a decision made in early April, when he placed a young queen into an upper chamber and left a divider in place that most beekeepers of his era would not have known to build. He had felt that weight before. He expected it. That expectation was the method, expressed in the only currency that apiary management ultimately answers to. When he stopped keeping bees, that knowledge went with him, not to a journal, not to an extension record, not to a publication that a beekeeper 60 years later might find in an archive and read and recognize for what it was. It went to the end of a season that nobody thought was worth writing down, because it was simply another year of results that the method reliably produced. The library didn't burn. It closed. And nobody made copies before the door shut. If the kind of reasoning that runs from biology through timing through outcome, without a product at any point in the chain, is the reasoning that fits the way you manage your hives, subscribe. There is more of this ahead, more methods that worked without commercial infrastructure attached to them, more timing knowledge that was precise and repeatable and then simply stopped being transmitted. And if you have run 2 queens, deliberately, experimentally, or by accident, and stayed with the outcome long enough to understand what you are seeing, leave that below. That kind of observation from a beekeeper who has actually held the frames carries weight that no general account can replicate.